In the first video for Unit 5, we are reviewing three topics, 5.1, 5.11, and 5.12. The tragedy of the commons, ecological footprints, and sustainability. Humans rely on the natural world for nearly everything we need to survive, from the food we eat to the air we breathe. Biological requirements, as well as the luxuries of modern life, are all made possible by what the Earth provides. As global populations grow and technology advances, our ecological footprints continue to expand, placing greater strain on Earth's shared resources. This growing demand can lead to situations similar to the tragedy of the commons, where the overuse of common resources harms the environment and everyone who depends on it. Understanding these challenges is essential for promoting sustainability, which focuses on meeting human needs today while protecting the planet for future generations. A commons refers to a shared resource that is accessible to all members of a community without private ownership or exclusive control. These resources are often collectively managed or used by a group, with the understanding that they benefit everyone. Examples of commons include public parks, community forests, and even the water stored underground in aquifers. The world's oceans, providing fish for food, grazing land for raising and feeding cattle, and the atmosphere are all commons on a much larger global scale. In all these examples, people rely on the resource for various needs, but it remains open for collective use. Although first described nearly a century earlier by a British economist, the concept of the tragedy of the commons was popularized by ecologist Garrett Hardin in 1968 in an essay that was published in the prestigious peer-reviewed journal Science. Hardin used the example of a shared pasture, or commons, where individual herders act in their own self-interest by adding more livestock, even though overgrazing ultimately destroys the resource for everyone. This idea illustrates how shared resources like air, water, fisheries, or public land can be depleted when individuals prioritize personal gain over collective sustainability. The tragedy lies in the conflict between short-term individual benefits and long-term communal well-being. Modern examples include overfishing in the oceans, deforestation of the Amazon rainforest, and carbon emissions contributing to climate change. Another example is the overuse of groundwater for agriculture, which can lead to aquifer depletion. Today, economists, governments, and environmentalists use the concept to design policies that encourage sustainable resource management and prevent this destructive cycle. An ecological footprint is a measure of the amount of land and resources needed to support a person's or population's lifestyle. It includes the resources used for food, water, energy, transportation, housing, and waste disposal, as well as the amount of land required to absorb the carbon dioxide produced. Scientists estimate ecological footprints by calculating how much biologically productive land and water are required to supply these requirements and resources, and to offset the waste that is generated. These data are often compared to the Earth's biocapacity, or the planet's ability to regenerate these resources. A larger footprint means that more resources are being consumed faster than the environment can sustainably provide. When many people exceed the planet's biocapacity, it leads to environmental degradation and resource scarcity. In this way, ecological footprints are directly related to the tragedy of the commons, as individuals overusing shared global resources can ultimately harm the collective well-being of all. Earth Overshoot Day is the date each year when a society has used up all of the biological resources that Earth can generate in that year. After this point, we are essentially operating in an ecological deficit, depleting natural capital and accumulating waste like carbon emissions. Sustainability is the practice of using resources in a way that meets the needs of the present without compromising the ability of future generations to meet their own needs. It focuses on maintaining a balance between environmental health, economic stability, and social well-being. Sustainable practices aim to preserve ecosystems, reduce waste, and minimize pollution so that natural systems can continue to function over time. Examples include using renewable energy, like solar and wind power, practicing sustainable agriculture that conserves soil and water, and designing eco-friendly cities with efficient public transportation and green spaces that utilize smart growth practices in city planning. This creates a sustainable, efficient, and livable community. And they all aim to curb the spread of urban land use, reduce environmental impact, and improve the quality of life. Overall, sustainability encourages long-term thinking and responsible management of the planet's limited resources. Maximum sustainable yield is the largest amount of a renewable resource that can be harvested or used without depleting the resource over time. It represents the balance point where resource use allows populations or ecosystems to regenerate naturally. For example, MSY applies to fisheries, where catching too many fish can collapse a population, or to forests, where harvesting too many trees can prevent regrowth. It can also relate to water extraction from aquifers or wildlife hunting limits. When people or industries exceed MSY, they increase their ecological footprint, using resources faster than can be replenished, and contributing to long-term environmental decline. MSY occurs at the point where the population growth rate is at its highest, typically when the population size is half that of carrying capacity. The growth rate of a population decreases as it approaches carrying capacity. Therefore, MSY is closely tied to both the growth rate and carrying capacity, as it represents the point where these factors balance for optimal sustainability. And since carrying capacity is difficult to accurately establish for a population, calculating the true MSY of a resource is no easy task. Thanks for watching, and until next time, take care.